Okay, so these diagrams. So we've started. And I really don't think that you guys want me to be telling you to be quiet when you're actually on the recording. You guys need to be paying attention to this. So put the freaking food away and pay attention. All right. Okay, so the diagrams depict inelastic collisions between objects of different mass. Okay, for each one of them, determine the post-collision velocity of the two coupled objects. So in all of these, the objects are sticking together, right? Look at the diagram. They're all sticking together after the collision. So after the last page, this one should be pretty easy for you, except there's no numbers. So we're using just the letters here. So for this first one, if this mass m is traveling v, it's going to have a momentum of mv, right? And it hits something else also mass m, but it doesn't have any momentum. So the total momentum before, okay, so the momentum before equals mv. Well, our momentum after is going to be 2m, right? Because we have two of them stuck together, so it's going to be m plus m, which equals 2m. And that becomes 2m v prime. Well, these two, and that's our momentum after. But these two should be equal to each other because of the law of conservation of momentum. So if mv equals 2mv, we want to solve for v prime in terms of the other v, in terms of what our initial velocity was. So if we're going to find v prime here, then we divide both sides by 2m, and the m's cancel. So v prime for this one would equal our initial v over 2. And that would be the answer. Okay, or 1/2 v, if you're more comfortable writing that. Okay, so let me pick another one down here. Okay, so I'll do f for you as well. Okay, so same idea happens. The total momentum here is 2mv. This one has a velocity of 0. All right, so this is going to be 2mv plus 6m times 0 gives us a total momentum of 2mv. Over here, these are together, so our total mass is going to be 2 plus 6 equals 8m. It's going to be 8m v prime. That's what that's what the apostrophe is called in this case, by the way. It's called prime. These two equal each other. We need to get this by itself, so we will divide by 8m to get it by itself. The m's will cancel. The 2 reduces with the 8 to give you a 4, and so we get v prime equals, no, not m, v over 4. And that's it for that one. Yeah? Okay, on the back side of that, okay, you want to complete the following verbal statements to illustrate your understanding of the effect of varying mass on a post-collision velocity. So, if an object of mass m collides in velocity v, so if an object, oh, let's get rid of that collides right there. Good. If an object of mass m and velocity v collides inelastically, Okay, which means they stick together. Okay, and I'll give you a demo of what elastic versus inelastic is. Okay, it collides inelastically with an object of mass 3m, which is initially at rest. Right, so you might want to draw your pictures on these. Gesundheit. Then the amount of total system mass in motion will increase by a factor of what? Well, if we go from m to m plus 3m, this equals 4m. Yeah? So this increases by a factor of 4. We're back. Okay, so you guys follow on this one. What it means by increasing by a factor of. We're back. Okay, what we increase by a factor of. Okay, so if we start with mass m, and then if we add a 3m to it, it becomes 4m. Well, what did we multiply this by to get to that? Okay, we multiplied by 4. Okay, that's what increasing by a factor of is. What did we multiply it by? All right, and the velocity of the system will decrease by a factor of, aha. Well, if we started with mv and we finished with 4 mv prime, right, what our new velocity would be. V prime will equal v over 4. So if our mass increases by 4, our velocity will decrease by a factor of 4. And the new velocity, so to decrease by a factor would be to divide, right? That you follow that? Okay, by what factor are we dividing our original velocity to get our new velocity? We're dividing by that same 4. And so our new velocity will be 1/4 v. All right, and you'll do the other ones just like that. Okay, and this one is just like the earlier ones we had. I'll do this one because it looks a little different from others. We've got a mass of 4.8 and a mass of 3.2 here. They're going to collide. They're going to collide over here, and so these two masses together are going to be 4.8 plus 3.2, which is going to equal 8 kilograms. So we have to go with what the momentum is afterwards to be able to figure out what this momentum was beforehand. If this is at rest, our momentum for this guy equals 0. Momentum over here is 8 kilograms times 6 meters per second equals 48 kilogram meters per second. Okay, well this is 48, and it all comes from this guy right here. What is his original velocity? All right, 48 divided by 4.8 is going to give us a velocity of 10 meters per second. Okay, so those are your examples for your homework. And go ahead and get started.